Hello, and welcome to this virtual introduction to 3D printing workshop offered by the Design Innovation Initiative at Kent State University. In this brief video, we will learn what 3D printing is and how it works. We'll discuss why 3D printing is such a useful and flexible tool and how it can be applied in a wide range of disciplines and careers. We'll show you how you can design and process a digital 3D model for 3D printing, and walk you through the process for using the Bamboo Lab 3D printers in the DI Hub's Reactor Makerspace to print your 3D model. First, let's talk about what 3D printing is and how it is different from other forms of manufacturing. 3D printing is a process of creating physical, three-dimensional objects from a digital design. It works by building up the object layer by layer, kind of like stacking very thin slices on top of each other, until the full shape is complete. This technique is called additive manufacturing because it adds material rather than cutting it away. The material used can vary depending on the printer and the project, but the basic idea stays the same. You start with a digital model, and the printer turns it into something you can physically hold in your hand. Now, 3D printing may seem like a new process, but has actually been around for a long time. It was first developed in the 1980s, with the first industrial applications following in the 1990s and early 2000s. The first at-home desktop 3D printer was launched in 2009, and within a couple of years, 3D printing companies, applications, and materials had already expanded rapidly. So, why would someone choose 3D printing? Like we said, 3D printing is what's known as an additive manufacturing process. You build an object by adding material layer by layer. In contrast, more traditional subtractive manufacturing starts with a solid block and then removes material, either by cutting, drilling, lathing, carving, or whittling, to shape the final object. From a sustainability perspective, additive manufacturing creates far less waste, since you're only using the material you need. It also unlocks much greater design freedom, letting you create complex shapes, internal structures, and even moving parts, all in a single print. Because the process is digital and streamlined, it's great for rapid prototyping. You can test, tweak, and reprint your designs quickly, which speeds up the innovation process. And unlike traditional subtractive fabrication, you don't need a bunch of specialized tools like saws, lathes, or grinders. One 3D printer can do it all, saving time, space, and upfront costs. There are actually several different methods used to 3D print an object, each with its own materials, strengths, and applications. The most common method, especially for desktop and educational use, is called fused deposition modeling, or FDM. That's the process we'll be exploring today. In FDM printing, a plastic filament is heated until it melts, usually at about 400 degrees Fahrenheit, and then pushed through a nozzle and laid down in precise lines to build up the object one layer at a time. You can think of it kind of like a high-tech hot glue gun, melting the material just enough to shape it, and then letting it harden as it cools. This process is simple, accessible, and great for prototyping and learning. What you're seeing here is an FDM 3D printer in action, specifically a multicolor Bamboo Labs X1E 3D printer from the DI Hub. It's printing a complex model of Yoda using multiple colors of filament, which are automatically switched out mid-print. You'll also notice some additional material being printed around and beneath the model. That's called support material. Supports are temporary structures that give the model something to build on when it has overhangs or includes bridges or gaps. Once the print is finished, those supports can be carefully removed. This time-lapse shows how the object is built layer by layer with incredible precision, just like we talked about earlier. Material jetting is another form of 3D printing that the DI Hub supports, and we can see it in this video. Material jetting uses inkjet-style printheads, much like a standard office printer, that lay very thin layers of liquid polymer resin. This resin is then solidified by UV light, layer by layer, until the final model is formed. Because this method uses jets of resin, it can print a single model in the full color spectrum with detailed colors and textures. Every day, 3D printing is being used in more and more industries. From healthcare to education, engineering to the arts, this technology is opening up new possibilities across a wide range of fields. Let's take a look at a few inspiring examples. 3D printing is making waves in the world of fashion and design. Designers are using it to create custom shoes with flexible soles, intricate dresses with patterns that would be impossible to sew by hand, and even fully 3D printed swimwear. Because 3D printing allows for complex geometries and custom fits, it's opening up entirely new ways to think about clothing, blending technology, art, and function in creative and unexpected ways. Chefs, bakers, and chocolatiers are also using specialized food-safe 3D printers to make incredible edible sculptures from dough, sugar, chocolate, and more. 3D printers have been used to make chocolate centerpieces, pancakes, pizza, cheesecake, like the one in the top left corner, and even steak.
A juicy, sizzling steak, made by computer. While obtaining regular meat is a process that's been taking place for millennia, cow, butcher, beef, Redefined Meat, a meat alternative startup out of Israel, makes their product using a highly technical process. The mix of soy and pea protein, chickpeas, beetroot, nutritional yeast, and coconut fat is formed into steak-like shapes using a 3D printer.
Our goal is to become the largest meat company in the world just by harnessing technology instead of animals.
Meat substitutes are not new, but unlike the soy-based crumbles that mimic ground beef, Redefined Meat's product is designed to act, taste, and cut like flank steak.
This is the holy grail of alternative meat.
But the most important part, how does it taste? This diner was happy.
The texture feels right. Even the smell smells like the real thing. Really authentic for me. Revolutionary.
3D printing is also making a big impact in architecture and construction. Using large-scale printers that extrude concrete, entire buildings can now be printed directly on site. This dramatically cuts down on construction time and labor costs, and it opens up entirely new design possibilities.
One layer at a time, Vulcan prints a full house. It goes from the front of the slab to the back for one layer. And for these homes in particular, after 10 feet of printing in a few days, you have the wall system for a house.
Because this 3D printing process doesn't rely on traditional molds or tools or materials, architects can create organic curves, intricate textures, and innovative structures that would be difficult or even impossible to build using conventional methods. There are also several medical researchers exploring 3D printing applications for healthcare. Researchers have used 3D printing to create customized prosthetic limbs, collagen implants to replace lost facial tissue, and even this example of an ear implant printed from living tissue. There are also researchers conducting research that explores 3D printable stem cells for even more complex biological structures, like the human heart.
Dr. Mark Schuyler Scott and his team of bioengineers are using advanced 3D printing techniques to turn a paste made of living cells into actual heart tissue. Goal? to one day be able to print crucial pieces of the heart, like valves and ventricles, that are living and can actually grow with a patient.
For adults, we have donor organs that can last 20, 30 years after transplantation, which if you're a 60 or 70-year-old adult is almost as good as a cure. But if you're a child at the age of 2 needing a transplant, knowing that after 20, 30 years, your transplant may be rejected by an immune reaction, then this is not long enough.
The concept of printing living tissue isn't new, called bioprinting, but it can be a slow process.
If you truly want to recapitulate everything about an organ, one might think about the need to write every single cell in its final location. Now, if you did that at a rate of about 1,000 cells per second, it would take over 1,000 years to make a single heart.
And that's where Dr. Skylar Scott's team made a breakthrough. They developed a way to print with clusters of thousands of cells called organoids.
We take millions of those aggregates and condense those into what is essentially like a human stem cell mayonnaise that we can then print through the printer. We can write very large and thick slabs of tissue that can really be used for transplantation in the future.
Now let's talk about how you can bring your own ideas to life using 3D printing at the DI Hub. The 3D printing process starts with a digital 3D model. You can create one yourself using computer-aided design or CAD software like Tinkercad, Fusion 360, or Blender. Or you can download a pre-made model from online libraries like Thingiverse.com or Makerworld.com. If you already have a physical object that you want to recreate using 3D printing, you can then use a 3D scanner to turn that object into a 3D model. Once you have your model, the next step is to prepare it for printing using slicing software. This software translates your 3D design into a series of printable layers and generates instructions that the printer can follow, also known as G-code. You'll also use the slicer to adjust settings like layer height, support structures, and infill density based on what your object needs, but we'll go over that later. When your file is ready, you can then visit the DI Hub's Reactor Makerspace to print it on one of our 3D printers. Our staff and DI crew are here to help if you run into any questions or need additional support along the way. Now let's learn a bit more about the DI Hub's printers and their capabilities. Before we do that, a quick note about 3D model files. There are many different types of 3D model files that serve different purposes in 3D printing. The most common is a .stl file, which stores only the surface geometry of a model in a widely compatible format. .obj files, or object files, go a step further, supporting color and texture details, making them useful for multi-material print. .3mf files are newer and more advanced, and include model data, colors, materials, and even printer settings. All three of these formats can be used with any DI Hub 3D printer. Lastly, .vrml files are primarily used for full-color 3D printing and store complex textures and color details. Each format has its strengths, but choosing the right one depends on whether you need simplicity, full-color detail, or advanced print settings. When it comes time to print, the DI Hub offers two main varieties of FDM 3D printers, the Bamboo Labs A1 and the Bamboo Lab X1E. Both are high-performance 3D printers that are available on a walk-in basis. The A1 is a reliable, user-friendly, single-color 3D printer that can work with plastics like PLA, TPU, and PETG. More on those later. This 3D printer is designed for consistent, high-quality prints and is ideal for general-purpose printing and education. The X1E, on the other hand, is a more advanced machine with enclosed build volume, higher speed printing, and better material capability. It is compatible with PLA, TPU, PETG, and ABS plastics, and can be used with up to 4 colors in one print. We also offer two specialty printers, the Stratasys J835 and F370, which are only available by appointment. Both printers cater to different aspects of professional 3D printing. The J835 is a full-color polyjet resin printer, perfect for creating highly detailed prototypes with lifelike textures and colors. The F370, by contrast, is built for functional parts and prototyping. It can print in a wider range of materials and uses dissolvable supports, making it better for mechanical components. Once you've selected the best printer for your project, you'll also need to select your model material. FDM 3D printing uses thermoplastic materials, each with its own unique properties. The most common are PLA, ABS, TPU, and PETG. PLA is the easiest to print, with a smooth finish and biodegradability. However, it is brittle and lacks heat resistance, making it unsuitable for high-stress applications. ABS is strong, durable, impact-resistant, and heat-resistant, making it ideal for functional parts. However, it requires a heated bed and good ventilation due to toxic particles. TPU is a flexible, rubber-like material, great for phone cases and wearables. It resists impact but requires slower printing and may cause more printing errors. Finally, PETG balances strength, flexibility, and ease of printing. It resists impact, moisture, and chemicals, making it a solid choice for mechanical and outdoor parts. Choosing the right material depends on your need. PLA for ease, ABS for durability, TPU for flexibility, and PETG for versatility. Once you have your 3D model file, you've selected your printer, and you've selected your material, the next step is to slice your model using a specialized slicing software. At the DI Hub, we use the Bamboo Studio slicing software, which is designed to work with our Bamboo 3D printers. Bamboo Studio allows you to manipulate the key settings for your model and then slice the model into G-code, the instructions that tell the printer where to go and what to do to print your model. Now let's walk through how to prepare your model using Bamboo Studio. Once you open Bamboo Studio, you can come up to the top right corner and click Create New Project. This will open up a new project with the print bed of the printer represented in the majority of the screen. You can move around this area by using the right mouse button to drag, the left mouse button to rotate, and the zoom wheel to zoom in and out. The first key step is to verify your print settings. You'll come over to the left panel here and make sure that the correct printer is selected. For most cases, this will either be the Bamboo Lab A1 or Bamboo Lab X1E. Make sure that the textured PEI plate is selected as the print surface, and that the diameter of the nozzle of the printer is set to 0.4. You'll then want to select the material that you plan to print this model in. In most cases, this will be generic PLA, but there are a number of other options here as well. Once you've verified your print settings, you can now add the model to the print plate. You can either do this by dragging and dropping the model into this workspace, or by clicking the Add button at the top and selecting your file. You can then see that your model has been added to the bed here. If you need to manipulate your model in any way, you'll want to make sure to select it and then use the tools up at the top to either move it, rotate it, resize it, or adjust how it's oriented. Just make sure that the model is completely flat on the print bed and is fully enclosed in the print bed. You don't want it off the side here. If you do that, you'll get an error message making sure you want to reposition it. So keep an eye out in this bottom corner for any error messages that pop up. Once you have the print settings and the model properly loaded, you can then play around with some of the print settings over here. We have everything from the layer height to wall loops, infill, and support. We'll talk more about these in just a moment. Just know that there are a number of print settings here that you can mess with if you so choose. The default layer height that we use is 0.2 millimeters. The default strength are 2 wall loops and 15% infill density. And if your model does have any overhangs or hollow areas, you'll want to make sure to turn on support by enabling support. There are many other settings in here that you are welcome to play around with or ask DI Crew to help you out. Once your model is positioned properly and all settings are correct, you can come up to the top corner to slice the plate for printing. This will turn your solid model into all of those layers, or that G-code, that the printer can then print. This may take a few moments depending on the size and complexity of your model. Once that process is complete, again, look out for any errors in the bottom corner. Looks like our slice is okay. And this menu will pop down with some additional information about your final print. This includes how many grams of this model will be used, the total print time, and you can also move through all the layers of the model to see how it will be printed over time. If everything looks good, you can then come up to the top corner and switch Print Plate to Export Plate Sliced File and export the file to your computer. That is the G-code file that you will bring with you to the DI Hub to print your file. And that's it. Your model is now ready to print. When processing your 3D model file using Bamboo Studio, there are several key settings that can help impact the quality and strength of your final 3D print. The first is layer height. Layer height represents the thickness of each layer of your model and helps determine the print's resolution. Smaller layers create smoother prints with finer detail, but take longer to print, while larger layers print faster but with a rougher finish. Walls, or perimeter, and sometimes called shells, form the outer shell of a print. More walls increase strength and durability, while fewer walls reduce material use and print time. Infill affects the internal structure of your model. A low infill percentage means prints are lighter and faster to produce, while a higher percentage increases strength. Different infill patterns can also impact durability. If the walls are a shell of an egg, the infill is the interior. Finally, supports are temporary structures that prevent overhangs from collapsing. They are necessary for complex designs, but must be removed post-printing, which can affect surface quality. Adjusting these settings helps balance strength, quality, and print time based on your project need. Finally, here's how the 3D printing process works at the DI Hub. Step 1 is to visit the DI Hub's Reactor Makerspace with your 3D model file in hand. There's no reservation necessary, just stop by when you're ready to print. Next, you'll process and slice your model using Bamboo Studio like we saw before. Bamboo Studio is available on all of the computers in the Reactor Makerspace, but can also be downloaded to your personal device for free. Remember, DI crew members are always here to help if you need it. Step 3 is to find an open printer that meets your needs and select your desired material type and color. Next, you'll complete one of our 3D print cards with your name and print information and show your file to a DI crew member to review. They'll help you process your slice model and calculate the print time and cost. We charge 8 cents per gram of material used. Once approved, you can send your G-code file to the printer via the provided SD card. Don't forget to get your DI crew sign-off before printing begins. Once you make sure your model begins to print successfully, you're good to go. There's no time limit for using our 3D printers, so whether your model takes 5 minutes or 5 days, you don't have to worry. You can then check back in the Reactor when the model is done and pay for your model. It's really that easy. Design it, slice it, get it approved, and let the printer do the rest. Again, thanks so much for watching. We're excited to see what you create. Stop by the DI Hub to ask any questions and start your printing today. Your ideas are ready to come to life.